Hello and welcome back. Today we're going from DNA to chromosomes. We talked about DNA earlier, but how, oh pray tell, do they become chromosomes? That's what we'll find out today. Ladies and gentlemen, our next topic is cell division. But before we can go into cell division, I want you to have an understanding of where DNA is in the cell division process. Right? Right. First off, what is DNA's structure again? Double helix. Excellent. These long strands of DNA in this double helix form need to be condensed into a very small space in order for the cell to divide. So how is this done? Well, let's take a look. Here we go. Step 1. 8 histones come together. See if I can find some histones for us to look at. There they are. 8 histones come together to form a disc. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Behind that we can't see. Around this disc, the double helix wraps itself twice. So here we have the double helix. If we kind of pull away from it, it looks more like a string. It wraps around each disc twice. So far, so good? Alright. Now, once they wrap around this, we give this special structure with the 8 histones and the DNA wrapped around it twice a special name called nucleosome. Each one of these is a nucleosome. This is a nucleosome, 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 nucleosome. So far, so good again? Alright. Now, this happens over and over and over again till we get a chain of nucleosomes. That's step 1. Are we ready for step 2? Sir, are you ready for step 2? Put that away, please. Alright, step 2! Oh, let me cover up step 3. Don't want to get ahead of ourselves. Step 2. The nucleosomes line up together into a spiral cord. Notice here are 6 of the nucleosomes. 1, 2, 3, 4, 5, 6. They are pancaked on top of 6 other nucleosomes, which are pancaked on top of 6 other nucleosomes, and so on and so forth. On top of one another for a very long time, all making a chain. Now, remember that each one of these little beads has the DNA wrapped around it twice. And there's 6 beads in one layer, and there's thousands of layers. That is a long strand of double helix. Okay? Now, during most of the cell's life, this is how its DNA exists. In a bunch of coiled or uncoiled nucleosomes. Okay? So far, so good. Why is it so important to have it neatly organized? So it doesn't get lost, doesn't get broken. So it works right. What is it we want our DNA to be able to do? Replicate, translate, transcribe, right? So we need to be able to access it, but at the same time it still needs to be put together in an orderly fashion, and this is what this this chain of nucleosomes allows us to do. Cool? Because they're still compacted tightly, but they're still easy accessible. Now, let's move on to step 3. Let's say our cells decide they need to start dividing. Well, we need to start wrapping these DNA up even, the DNA up even tighter. In step 3. Now, we see a protein scaffold here. If you see this like darker blue line that goes in a spiral, that is a long protein chain. Okay, we call it a scaffold because this nucleosome fiber is going to attach itself to it. Now this protein is wrapped tight like a spring. Think of a spring wrapped, spiraled on top of itself, tightly packed. What the nucleosome cord does is it starts looping itself, attaching itself every once in a while on this protein scaffold. back and forth, back and forth, back and forth, as you can see. Now, let me ask you something. If you have a piece of string, a long string, say it's 3 feet long, and you start wrapping it back up on itself, is it going to take up more or less space? Much less space, right? But is it going to be any shorter of a string? No, that's the idea behind this. You're taking a huge long string and making it shorter. Cool? Alright, groovy. Okay. So now, we have our DNA wrapped around 8 histones, making up a nucleosome. These form a pearl necklace-like structure, which then spirals in on itself, compacting even more, which then attaches to a protein scaffold, getting even tighter. Now it's time to move on to step 4. Too fast? Too slow? We good? Alright. Step 4. Oh, I better cover up step 5. Phew, that was close. Step 4. Alright. In step 4, this protein scaffold we talked about forms a spiral shape, kind of like that spring I was talking about. And the spiral string, along with the DNA, this nucleosome cord wrapped around it, forms a highly condensed DNA, a rod-shaped structure known as a chromatid. This one side is a chromatid. Okay? So that protein scaffold wraps itself tight, tight, tight like a spring and makes this one side. Okay, I'm going to go back one time. Here's the nucleosome cord wrapped around the protein scaffold. See how it's getting tighter and tighter of a spiral down below? That leads right into the top of this one. So it's a tight protein scaffold all the way up and down this one side of the chromosome. This is a chromosome. This is a chromatid. So far so good. Any questions? Alright. Give you a chance to write that down, and then we'll move on to step 5. Now, what did we learn our DNA does during replication? Makes 2 identical copies of itself, right? Okay. That second copy doesn't just get thrown away. Same thing. That second copy of DNA wraps around nucleosomes. Nucleosomes. Wraps around, makes a cord. Wraps tightly around the protein scaffold. Makes a tight spiral. And that is what it's on the right side. This chromatid on the right side is identical to the chromatid on the left. Okay? Exact same DNA. But together we call them one chromosome. Okay? Chromatid, chromatid. Identical. Consider them twins. They're held together with a centromere in the middle. Okay? Questions? No questions? You guys got this? You good? Okay. So how many copies of DNA do we have in one chromosome? 2. Yes. This is going to get a little trickier when we start going through mitosis and meiosis, so I want you to understand that. This left side is identical to this right side. Went through the same process, double helix, wrapped around twice, around the beads, on and on and on. There's 2 copies of DNA in each chromosome. That's exactly correct. Each chromatid holds a copy. Now I think my next slide has it all put together. Let us see. Yes. So now, here it is all put together. We have our DNA double helix coming together and wrapping itself twice around each disk of histone, making a nucleosome. The nucleosomes all packed together in a nice 6 together, forming a layer, which is on top of another layer, which is on top of another layer, making a nucleosome fiber. This fiber then starts wrapping itself around the protein scaffold. The scaffold starts tightening in on itself like a spring, tighter and tighter and tighter, till it becomes one long spring with a bunch of the fiber wrapped around it, making up a sister chromatid. Okay. And then over here on this side, exact same thing happened already. So these two are identical. Genes become DNA, go to nucleosomes, go to chromatin, becomes a nucleosome coil, goes to the protein scaffold, becomes a chromatid, two chromatids become a chromosome. Now, we went through that really fast. Is it good stuff? Everyone good? Alright, no questions? You guys got it? That is the end of our discussion. We started with DNA and went all the way through our lovely little journey all the way into a chromosome. Nice work, everybody.